Hi everyone, Assalamualaikum. My name is AISYAH Binti HALIZAN from Mat 1 and today I will present the Task 2 project. I start with introduction. So in this project, I apply the concept of partial derivative to real life business situation involving the big company in the world, which is Nestle. So in Nestle Malaysia, they have a product which is Milo. So the goal is to analyze how changes in the number of Milo units sold and the distribution of free samples affect the company total profit. So by using the multivariable function, I calculate the first and the second derivative to find the critical point and understand the behavior of profit in response to this factor. This analysis help how mathematics, especially calculus, can support smart business decision. So, in this project, I have chosen a problem statement, which is this study explore how Nestle Malaysia can increase profit from its product, which is Milo, by finding the optimal number of free sample to distribute and the ideal number of products sold. The total profit in model by the function. So this is the function which is 800x minus 2x squared plus 600y minus y squared plus xy. So this is the function that I choose in my project. Based of the equation that I have chosen in my project, I have generated a 3D graph from Wolfram Alpha software. So from this graph, we can see that the graph is shaped like a concave surface. It's like a hill shape. So this shows that profit increase up to a certain point, then start to decrease if either variable becomes too large. So this is a typical in real life business, which is if you're spending too much on free sample or in produce a product, so eventually it will also reduce the profit. So we can see the shape. There is a highest point on the surface, which is it shown the maximum profit. Let me explain relate to the company that I choose, which is Nestle. So, if Nestle give too few free samples, it might not boost the product sale enough, so the company will get the low profit. But if Nestle give too many free samples, the cost become too high. So it also make the profit drop. Similarly, by increasing the number of products sold doesn't guarantee that the company will have a big profit unless the free sample have their own strategy to support it. So the best profit is achieved by finding the optimal balance of both with how many sample to give and how much to sell. It must connected to each other and then the company will get the big profit. As you can see here, this is a 2D graph that I generate using Wolfram Alpha for the contour. So using the equations that we get before, which is 800x minus 2x squared plus 600y minus y squared plus xy. So actually, as we can see in the graph, each curve in the contour line shows combination of x and y that give the same profit level. So the plot helps to identify the optimal strategy. So what it means for Nestle is the center of the contour, which is the lightest area, show that the point of maximum profit, where the right balance of sample and sales is achieved. So going too far in either direction, which is giving too many samples or trying to sell too much products, move you away from that center. It will causing it, it is it is causing diminishing returns, just like the negative squared terms in the function, which is negative 2x squared, negative y squared. So therefore, Nestle must carefully decide how many free sample to distribute to encourage product sales without overspending or lowering total profit. Okay, we proceed to the solution now. First thing, we need to find the first partial derivative. So from the equation that we have, we need to respect to x and we treat the y as a constant. So as you can see, I have put the red box on the equation, which is 800x minus 2x squared and xy. That is the number that we can differentiate because it has x. So we get the 800 minus 4x plus y. As you can see, this is the answer for the first partial derivative for respect to x. So this equation tells us that how profit respond to more free sample. As we can see, the equation is 800 minus 4x plus y. So each of that number shown that 800 shown that every free sample give an initial boost in the profit, and negative 4x shown that if too many samples are given, it will become less effective or cost too much. That we call this diminishing returns. But by plus y, the more product we sell, then the more valuable each free samples become because they support each other. Now we continue the first partial derivative with respect to y. So we treat x as a constant and differentiate. So as you can see, I have done put all the red box on the numbers, and then we will get, after differentiate, we will get 600 minus 2y plus x. From that equation that we have done differentiate, so this equation tell us how profit change when Milo is sold. So the 600 shown that each product sold adds to the profit. And then the negative 2y shown that by selling too much may require discount, higher logistic costs, and it will not give much profit to the company. And also the plus X shown that the more free samples you give, and then the more sales you can make by support each other again, like the respect to X. So this is the 3D graph from first partial derivative respect to x that I generate from Wolfram Alpha software. So as we can see, this surface is sloping downward slightly, suggesting that increasing free sample initially boosts profit, but then the profit will increase at a slower rate. It is because giving away too many free samples can become costly if they do not convert into the product sales. So this means free samples are good, but only in certain limit. Beyond that, they will hurt the profit instead of helping the sales. Now, this is the 3D graph for first partial derivative respect to y. So from the equation 600 minus 2y plus x, I generate using the Wolfram alpha, so I get this 3D graph. So as we can see, the surface is gradually increasing, which suggests that as you increase product sales, the profit will increase, but not linearly. So the surface isn't steep, which is the rate of profit increase slow down over time, and you get diminishing returns from selling more unit. So this is makes sense in business because after a certain point, selling more product may require extra costs like storage, marketing, logistics, so the profit rise more slowly. The next step is we need to find the critical point. So how to find the critical point? First thing is we need to set both derivative to 0 to find the value of x and y that give the highest profit. So we have two equations here. We equal both of them to 0. So from the first equation, we can get the y equal to 4x minus 800. That is our third equation. So we substitute the third equation into second equation to get the x. The x is the number of free sample to distribute, which is we get the answer x equal to 314.29. Now we substitute back to find y. We substitute the answer of x into the y equation, and then we'll get the y, which is number of products sold, which is 457.14. So we get the critical point is 314.29, 457.14. So from this, we know that Nestle can strategically plan marketing campaigns, which is distributing 340 samples per region and set sales target of about 457 units to ensure optimal return for the company. The next step, we find the second derivative test from the partial derivative that we have respect to x and y. Now we compute the second order derivative with respect to x. As you can see, I have put the red box on the negative 4x. We differentiate that number and then we got the negative 4. Why we got the negative 4? Because the profit decreased as too many free samples are given. So this means the cost of giving out the samples eventually outweigh the benefits. So now we see the partial derivative with respect to y. So now we will respect to y. So we look at the negative y. So we differentiate it and then we got the negative 2. Also negative. So the profit also will decrease as too many units are sold without support or balance. So possibly due to increased operational cost or market saturation. Now we proceed to the mixed partial derivative. After we do the both of mixed partial derivative, we got the answer is equal to 1. So 1 is a positive number, so there's a positive interaction between free sample and product sales. So by giving out the samples, it helped to boost sales and increase profit up to the point. Next, we form the Hessian matrix. So I have shown the form of Hessian matrix. We got the negative 4, 1, 1, and negative 2. So this matrix will help analyze the nature of the critical point. So we find the determinant of Hessian, then we got number 7. So we can conclude that since determinant of Hessian is 7, and it is bigger than 0, and also the second derivative respect to x, we got negative 4 with less, which is less than 0. So this confirm that the critical point is a local maximum. So the Hessian and its determinant prove that there is an optimal strategy for balancing free samples and product sales to maximize profits. Going beyond this balance is either direction cause profit to decrease. Because of the second derivative respect to x, we got the negative 4, so the surface curve downward. Before I end my presentation, so I will explain the conclusion. In conclusion, our calculation and graph show that Nestle company can maximize profit by finding the right balance between giving samples of Milo and increasing product sales of Milo. So the critical point and second derivatives test is used to confirm the optimal strategy, helping guide better business decision through calculus calculation. That's all about my presentation. Thank you, Puan Amalia, for lending me your ears and eyes to watch my video. I love you so much. Bye.